Alrighty, welcome guys to my first YouTube video. Excuse me if this video is a little rough on the edges. I'm still experimenting with this particular type of content. I haven't done many videos before, so again, please excuse me if this is a little rough on the edges. But anyway, today we're going to be doing something on configuring OSPF. So we're going to have two routers that are connected peer-to-peer. Got this link right here, and we're going to be configuring an OSPF adjacency between them and advertising some loopback routes. And before we get into any more of the technical content of this video, I just want to make clear one thing. This video assumes that you already understand the prerequisites of OSPF conceptually, at least from a CCNA level. This is a CCNA level video, CCNA level configuration of OSPF, so we're not getting into the more advanced topics like virtual links and all that. This is going to be a simple adjacency and advertising some routes, so we have an O route in the routing table, no redistribution, no external routes. But it still requires that you understand, for example, what OSPF is, why you would want to use it, why you would want to use a dynamic routing protocol in general. You need to understand that OSPF is a link state protocol and what that is and how it differs from a distance vector protocol, why you would use over static routing. Basically, the basic overview of OSPF from a conceptual point of view is what you're expected to go into this video with. If you don't, I would suggest either watching another video, or I have videos coming out in the future that cover OSPF from a more conceptual standpoint. So if you're watching this video in the future and I've already published those OSPF videos, they'll be included in the description. If you want to go take a look at those, understand OSPF a little more before you go into configuring it, that would be the best. Also, we are doing OSPF and not EIGRP or BGP because on the new CCNA 200.301, the one that's coming out on February 24th, which is just a few days away now. So if you guys are doing CCNA RNS, you should really hurry it up if you haven't already. But on the new CCNA 200.301, this is the only routing protocol that's covered on the objectives, which is actually surprising because I would think that RIP would be covered as well, given that RIP is significantly simpler than OSPF, but whatever. There's also static routing if any of you smartasses in the comment want to come in with, well, there's also static routing, yeah, but static routing is their routing protocol, and let's be quite honest, I'll do a static routing video later. But for now, this is just going to be a test run video where we cover OSPF. Cool. So you can see in my GNS3 that's been kind of resting here. We have two routers, right? Those simple two router peer-to-peer topology with the link that terminates on gigabit Ethernet 00, as my face is covering. That terminates on gigabit Ethernet 00 on both routers. So if I go ahead and drag my command line interface over here, you can see this is a show interface gigabit Ethernet 00, and you can see the internet address, the IP address, as 10.0.0.1/30. So we use a /30 subnet mask, that's 255.255.255.252, to terminate a peer-to-peer link, because a /30, well, it has 4 addresses total. If you subtract 2 for the network ID and the broadcast address, you have 2 host addresses, which is perfect for a peer-to-peer link between, in this case, routers. Oops, did not mean to do that. So as you can see, we have 10.0.0.1 configured here. Router 2, we have 10.0.0.2 configured over here, and you can see our ping results from one router to the other. In this case, this is router 2 to router 1. You can see that ping to 10.0.0.1 works perfectly. So we have connectivity between these two routers. So what's the next step then? Well, we have to configure OSPF on both of them. So how you do that, and this is not just for OSPF, this is for any of the dynamic routing protocols, right? That iOS supports. You go to router, right? And if I do a context help here, right? You can see BGP, EIGRP, ISIS, OSPF, IPv4, OSPF v3, and RIP, right? So there's a lot of routing protocols that you can choose from here. In this case, we're going to be doing router OSPF, right? And if I just do this, it'll say incomplete command. Well, let's do a question mark again and see what we're missing. So you can see we're missing a process ID. The important thing to know about a process ID, and I'll actually show it here, the process ID is what we define as locally significant. What the hell does that mean? Basically, something that's locally significant is only significant to your local router. Wow, I know, what a revelation, right? So it doesn't actually get transmitted in any kind of OSPF update, and it's not like if this doesn't match, the adjacency is not going to form. No, you can have the process ID is just for local identification on a single router. I could have R1 with a process ID of 1 and R2 with a process ID of, I don't know, 69. And it would still form an adjacency as long as all the other parameters that need to match between an OSPF router, or between OSPF routers, do match. So in this case, I'm going to do 1. Is this a complete command? You can see, yes it is. VRFs are a CCNP concept. You don't need to understand that as CCNA. And CR means that I can just hit enter, and there we go. We are in a new subordinate configuration mode, config-router. If I do a question mark here, let me get my dock off the screen. We have a lot of commands here that are available for us. So OSPF is a very, very in-depth routing protocol. You can see here we have a ton of stuff we can mess around with. In this case today, we're just going to be using the network command, right? The network command in OSPF, and when you learn BGP, you'll learn that this definition kind of morphs a little bit, but in your interior routing protocols, EIGRP, RIP, OSPF, the network command does various things. It does 3 main things. The first thing that it does is that it advertises whatever whatever networks are on interfaces that fall within the network that's defined. What do I mean by that? Okay, well, let's look here, right? Do show IP interface brief, right? I have this gigabit Ethernet 00 with a assigned network of 10.0.0.0/30. I understand that the assigned IP address is 10.0.0.1, but the network, the subnet that this interface is part of, is 10.0.0.0/30, and that includes 10.0.0.1 and 10.0.0.2. So the network command takes the network that, if I say network, right, you can see I have a network number, right? Seems fairly obvious. Well, there's a lot of ways I can define this network number. The network command just does a simple matching mechanism. It's not like BGP where it's an exact, like, match, right? This is just like, it's a scope. So if I do 10.0.0.0, right, and then this is a wildcard mask, right? That's important to note. It's not a subnet mask. So a wildcard mask 255.255.255.0 and a subnet mask 255.255.255.0 are wildly different concepts. In this case, the wildcard mask is just a flipped, inverted version of the subnet mask, right? So if you have a subnet mask of 255.255.255.252, right? That's 30 ones and 2 zeros. Well, now you have 30 zeros and 2 ones, right? 2 ones is 3, so it's 0.0.0.3, right? Area 0, and I'll cover that in a second. But you can see here, right? 10.0.0.0.0.0.3. That's going to match gigabit Ethernet 00. Now, here's another thing, right? I don't have to define it that way, right? Because hypothetically speaking, right, and this is actually impossible if you're a routing process, right? But let's say that were possible. Let's say that we had another interface, right, that fell within the subnet. Or actually, just as a better example, let me go ahead and negate this command real quick by proceeding with no, right? Let's say we have network, let's say 10.0.0.0, 0.255.255.255 area 0, right? And what that's saying is this is the inverted subnet mask, right? Or, well, this is a wildcard mask, which is an inverted subnet mask. So this is saying 255.0.0.0. So what that's saying is match any interface that has this first octet of 10, and I don't give a crap about what these last 3 octets are. Well, I can definitely think of a case, right? Because these are a /30, right? The rule of routing is that you can't have interfaces on the same router that have the same subnet. Well, I could definitely, if I subnet down 10.0.0.0/8, which is what this effectively is, I could definitely have interfaces on my router that have the same first octet of 10. Let me show you, right? If I go ahead and do int g0, or let me make a loop back. If I say network 10.111.255.255.255.0, not network, IP address. Oops. Right? Valid command, and it's accepted. Right? But the thing is that this is still being advertised into OSPF. Even if I only want Gigabit Ethernet 0.0, if I do a general network statement as this, right? If I do show IP OSPF interface brief, which is a command you'll see in a second. Interface, see we have this loopback, right? Well, what if we don't want that? The solution to that is a number of solutions, actually. We could do it so that our network statement is more specific and only hits that subnet, that particular interface, right? If I do a show IP OSPF interface brief now, you can see it only hits the Gigabit Ethernet 0.0 interface. But what's important to remember is that it's just a matching mechanism, right? That's one important thing to remember about the network command. And why do I say that? Going back to what the network command does, it advertises the networks that are part of interfaces with IP addresses or with associated networks that match the network statement. And that's a loaded statement right there. I know that may sound super confusing, but here's what it really boils down to. When I define a network mask, I'm defining a scope that I'm willing to accept, right? In this case, I said 10.0.0.0.255.255.255. So I said, look, I'm willing to accept in this network statement, I'm willing to accept any interface that has an IP address that begins with 10, right? Or any interface that has a associated subnet that begins with 10, right? Point being, at the end of the day, this just defines the scope. When I had a general network statement, I hit multiple interfaces, right? Because I configured this to be 10.1.1.1, even though this looks wildly different from G00, because they've all had the first octet of 10, they both got hit by OSPF's network statement here, and they got advertised in. So it's important to note that it searches the router for interfaces that match that network command, and it advertises the prefixes into OSPF, as you can see here when I did a show IP OSPF interface brief, which is one of the verification commands you can use to make sure that interfaces are actually being hit by your OSPF network commands. The second thing that it does is it does an active neighbor search, and that's going to be more apparent when I configure OSPF from router 2. But it does an active neighbor search. It sends out hellos, right? Hellos are OSPF's way of saying, hey, I'm on this link, right? I am on this subnet. I exist, right? Are there any other OSPF neighbors out there who want to join me? That's what a OSPF hello packet is. So it starts actively sending those hello packets at the configured hello interval, right? Just by default. Let me show you. Actually it's not this command. Show IP OSPF interface, because the hello interval is based on the interface. So if I go G00, right, this will tell me that the timer intervals are configured and that the default is 10. You can have different hello intervals based on different interfaces, but for the most part, when you're using Ethernet interfaces that are connected to a switch or that are connected to other routers, your default hello interval will be 10, and your default dead interval will be 4 times higher than your hello interval. Your dead interval is something different. We'll cover that in the more conceptual overviews of OSPF. But, right, the network command, the second thing that it does is it sends hellos at this pre-configured default hello interval, right? So every 10 seconds, hello. Every 10 seconds, hello, right? Are there any OSPF routers out there? The third thing that it does ties very closely into the second thing that it does. The third thing that it does is it listens for other OSPF routers that are sending in hellos, right? So it's sending out hellos, but it's also listening for other people sending in their hellos, right? So router 2, when I configure OSPF on him, he's going to go through the same process. He's got to send out hellos. He's going to say, hey, I am on this segment. Who else is there to neighbor with me? Router 1, as a result of that interface being matched by the network statement, will see that hello. It will do its check. It'll compare its parameters, which again is a process I will review in a later video. But it'll look at the parameters, and if everything is matching up to its satisfaction, R1 will say, hey, I want to be a neighbor with you. I want to form an adjacency, and it'll go through the OSPF adjacency process. But that's just a basic overview of what the network command does. Now I'm going to configure the network command on router 2, right? Router OSPF, again, I need the process ID, and just to prove that they can be different and still match up, I'm going to say network 69, right? Or process ID 69. I'm going to say network 10.0.0.0, or let's just show you how I can define a scope, right? So let's say I want to just hit one interface, right? Well, couldn't I just hit the IP address? Because the thing is that the router takes the network command scope, the one that's providing the network command, and looks on the router for interfaces that match. Well, or interfaces that have IP addresses that match. Well, couldn't I just say list? Because 0000 means all 32 bits, right? So 0000 in this case would be equivalent to a subnet mask of 255, 255, 255, 255. What that's effectively saying is this has to match the list IP address exactly in order to be advertised. Actually, since it's router 2, I should be changing this to 2. Excuse me there. But I could just say that, right? And if I do, you can see there, OSPF adjacency change process 69, neighbor 10.0.0.0.1 or 10.0.0.1 from loading to full. Full meaning that it is a fully established OSPF adjacency, right? If I do a show IP OSPF interface brief, you can see even though I hit this exactly, right? I didn't say network 10.0.0.0.0.0.3, right? It's still matched. And one important thing that you can take away from this also is that the network commands don't have to match between two routers. They're not, in that sense, super strict, right? It's just that the network command, again, just defines a scope. I can't hammer that in enough. It just defines a scope on the router where it's willing to accept interfaces in to be advertised in that particular OSPF area. Again, areas being something that we'll touch on in a little more detail in a later video. So, now we have an OSPF adjacency, right? But having an OSPF adjacency, we can verify that on any of the routers involved by saying show IP OSPF neighbors, right? You can see neighbor ID 10.0.0.2, state full. This BDR refers to the designated router, backup designated router relationship on broadcast networks, which is something we can cover later. At that time, the actual IP address. So it's important to differentiate between these two. This is the router ID of the neighbor. And in fact, I can configure router ID by going into the OSPF process configuration, saying router ID, and this can be any 32-bit dotted decimal number. So when I say dotted decimal, I mean in the same form as an IP address, right? If I go clear IP OSPF process, right? Clear IP OSPF process is a command that lets you kind of like nuke your OSPF. It restarts the OSPF process effectively. But you can see on router 2, right? I configured the router ID in router 1. You can see neighbor 0001. Well, you say, wait, that's not a valid IP address. I can't 0001 on an IP address. Okay. But if I go and show IP OSPF neighbor, right? You can see neighbor 0001, priority 1, full. This is weird. It shouldn't be listing both. Let's do a clear IP OSPF process on this one, and we'll see if that clears up. Show IP OSPF neighbor. There we go. That was weird. But you can see neighbor 001, right? State full, and then we have the actual IP address. So it's important to differentiate between these two. And the router ID's use comes more into play when you understand, when you talk about like the conceptual overview of it, which again is something we'll cover in a little more detail in later videos. But yeah, this is just one important differentiation to make, and then interface is the interface that you can use to reach that neighbor. Or shall I say, the interface that the neighborship was formed over. With that being said, let's do one last thing. We're going to advertise a route, right? Well, how do we advertise a route, right? There's nothing connected here, right? There's no route anywhere. Well, that's true, right? Because we have a connected route for the link, so we can't advertise that through OSPF because of an administrative distance thing, right? If I advertise the subnet through OSPF, and it is actually being advertised right now, OSPF has it, and we can verify it by saying show IP OSPF database. That prefix is being advertised, right? It's just that it's not being accepted because of an administrative distance thing. Connected routes will always beat out OSPF routes. OSPF has an administrative distance of 110. Connected routes have an administrative distance of 0. And the lower administrative distance is better. So you're never being out a connected route. Well, what can we do, right? Well, we have to configure a network that one of these routers doesn't know about. We have to configure a network and advertise it into OSPF, where the OSPF route is the best one that router knows about. What better way to do that than a loopback, right? Because I don't want to add a separate switch here and a separate link. That's too much of a pain in the ass. No, we're just going to make a simple loopback interface. I'm going to do loopback 1, and we're going to do IP address, right? And I'd like to make, you can pick any IP address you want here, really. I do 1111 because it makes it easy to identify what router it's coming from. I do a host address because if I make any more loopbacks, I can say 1112.255.255.255.255, right? Now I have a couple of loopbacks created, right? Let's make sure that router 2 doesn't know about this. And he doesn't, right? He just has his connected routes for the local subnet of Gigabit Ethernet 00, right? Well, I don't know about these loopbacks, so OSPF is going to be his best way in this current topology to get him to these loopbacks, right? So let's go into our OSPF process, router OSPF1. We're gonna say network. Let's advertise all of these loopbacks, actually. He doesn't know about the 10.1.1.1, right? So we're gonna hit that in, right? 10.1.1.1. 0000. I have to specify the OSPF area 0, right? We're just doing a simple single area configuration, nothing multi-area for CCNA. And then we're gonna do the rest of these commands, right? Or gotta remember the area statement. So how do we advertise? How do we check what interfaces are being advertised into OSPF? What command do we use? Well, hopefully you answered. Show IP OSPF interface brief. You can also do show IP OSPF interface, but that requires that you specify an actual interface, right? But show IP OSPF interface brief, just like show IP interface brief, will show you the actual interfaces that are being hit by your OSPF network statements. And you can see we have our 3 loopbacks and the link that's actually being used to power this OSPF adjacency. If I do a show IP OSPF database, right? Yeah, so this is show IP OSPF database router. Shows you detail, right? So if I just do a show IP OSPF database, this doesn't really tell us much, right? To understand what you're telling you is more of a conceptual explanation, which I want to avoid right now. But if you want to look at the actual networks that are being advertised, right? In most cases, you'll want to use show IP OSPF database router. At most cases at the CCNA level, right? Show IP OSPF database router will show you the contents of what we call LSAs, link state advertisements. Sorry. And you can see, right, we have 10.1.1.1, 1.1.1.1, 1.1.1.2, right? These are our loopbacks. If I do a show IP interface brief, you can see that these are indeed our loopbacks, 10.1.1.1, 1.1.1.1, and 1.1.1.2. So these are being advertised in the OSPF, and as a verification step, if I do show IP route, right, here we are. We have O routes, and if you look at the key, the legend up here, O routes are OSPF routes, right? So we have O for 1111, O for 1112, and then we have O for 10111, right? And this is a 110. This bracket here, this is administrative distance. So this is, again, this determines the trustworthiness of the route compared to other routing information sources, right? So a lower administrative distance means the route is more trusted, means that in a competition between two routing protocols, the lower administrative distance one would win out in terms of which one goes in the routing table. And then we have cost, right, which is the local routing protocol metric that we use to determine within the routing protocol itself what route we would prefer if we have, say, two routes to the same subnet, right, to the same prefix, to the same place. And if I wanted to just filter for just OSPF routes, because in a corporate routing table this could be many lines long, you can do a lot of things. But if you just want OSPF routes, say show IP route OSPF, and it'll show you only the OSPF routes, right? If I ping 1111, you can see, right, that this works. Now, just to show you that OSPF is the reason this is working, I'm going to shut down. I'm actually going to. I'm going to show you that this is. I need to figure out what network command I used first. Here. So router OSPF1, no network 10.0.0.0.0.0.0.3 area 0. Alright, cool. Adjacency down. Right, do you see we don't have OSPF route in the routing table, and we shouldn't have OSPF routes in the routing table anymore. Oh, yeah, okay. So show IP route, sorry. So you can see we only have the connected routes, right? I was doing the OSPF tag and I was confused why the connected routes weren't showing up. Anyway, so now if I do a ping to 1111, this should not work. And it doesn't, right? Because it doesn't know where the network resides, because OSPF was the one providing that information, and when OSPF went down, so did the routes. Actually, I'm actually going to go in right now to clear the process. I'm going to clear the process over here because there's one last thing I want to cover. I'm going to change the router ID over here to 002 so you can identify it. I'm basing these router IDs off the router name, by the way. And again, your router IDs don't have to be valid IP addresses, they just have to fit the 32-bit dotted decimal notation. But the last thing I wanted to cover was another way you can configure OSPF that you might be expected to know as CCNA, right? Because the network command isn't the only way you can configure OSPF. Actually, in OSPF v3, which I don't think you're expected to know as CCNA, the network command is just gone, right? For IPv6, the network command just doesn't exist anymore, right? So you have to use a different way to advertise interfaces in, and it's pretty easy compared to advertising wildcard maps and figuring out what matches an interface and what doesn't, right? It's pretty easy. Just go into the interface, right? So keep in mind this is process 1. That's going to be important in a bit. I'm going to say Gigabit Ethernet 00, right? I'm going to say IP LSPF. You can see there's a lot of parameters here, but what you're looking for is list top one, right? Process ID. Okay, well here. 1, right? Router OSPF 1. It's important to note that you don't have to, because if you don't do this beforehand, it will do it for you. But you should be defining your OSPF process beforehand. And that, in this case, I just did it so I could define my router ID early. But as best practice, you should be defining your OSPF process early, because there's still, this just replaces the network command. There's also other things you can do in here, authentication, stuff like that, that are above CCNA, right? But there's still a lot of things that you need to be doing at the OSPF subordinate mode, the config router mode, right? This just replaces the network command, or this just is substitutes for the network command, right? But anyway, IP/OSPF, we give it the process ID that we configured up here, area, and then we give it the area that we want, right? You can see here there's OSPF area ID and IP address format. That's something that you don't have to worry about, right? But you can see 0, so I'm going to tell it 0. Well, how do we verify that worked, right? Show IP/OSPF interface brief. You can see that we have our interface here, right? And if I do the same thing on router 2, in this case, I'm going to say 69 because that's my process ID. Area 0, right? This is the same thing as network command. If I hit end, you can see very quickly, two-way, this is going through. You can see that the neighbor is listed here, right? It's going through the motions of getting the OSPF relationship up, hopefully. Clear IP/OSPF process. There we go. For some reason, these images seem not to be playing fair today. But if I do a show IP/OSPF neighbor, right, this is full. Just like earlier, right? Just like earlier when we were using the network command, right? We did our neighbor ID, our address, right? This stuff is showing up here. If I do int range LO0 to 2, IP/OSPF 1, area 0, right? Again, similar to the network command. If I do show IP/OSPF interface brief, see my loopbacks are in here. If I do a show IP route, my OSPF routes are here. If I ping 1.1.1, exact same result. Nothing different at all. The only thing, if you look on R1, we go to show run, show running config. You can see, I would use a regex to filter all this out, but I'm walking you through it anyway, right? Router OSPF 1, there's no network commands on here. I configured my OSPF processes to run under these interfaces, right? As you can see, there's no mention of a network, no mention of a network number, no mention of a wildcard mask. This is a direct reference, right? And it's important to note that I can't think of a reason why you would want to, but if you wanted to, you could have some interfaces that are matched by network command and some interfaces that are matched by list command right here, right? This IP/OSPF process ID, it doesn't have to be one area, right? And your area number that you want to be advertised into. Most times, if you're doing single area OSPF, it's just going to be that one number. Most people use 0 when they're doing single area OSPF, but if you're doing multi-area OSPF, where you can have topology where multiple of these area numbers are in use, right? You just define your area number. No mention of a network command, or no mention of a network number, no mention of a wildcard mask, and you're advertising an interface into OSPF. You can see here, but again, if I do show IP/OSPF interface brief, these interfaces are present. If I do show IP/OSPF database router to look at the router type 1 LSAs, you can see these are still present as stub networks. These are still in the OSPF, we call it the LSDB, the link state database. So stuff is being advertised into OSPF. So that's the two ways that you can configure OSPF. You can use the network command from within the router configuration mode, which you get into by using the router OSPF process ID command, filling in process ID for whatever your process ID is, or you can advertise it directly from the interface. We looked at the clear IP/OSPF process command, which lets you reset the OSPF process in case there are any issues. And we looked at 2 verification commands, even more maybe. Show IP/OSPF interface brief and show IP/OSPF database router, or with the optional router keyword, to look at the specific contents to make sure stuff is being advertised. And of course we have show IP route OSPF, which on this router will show nothing because this router is the one that's actually advertising stuff out. So if there's anything that you take away from this video, that's it. Once again, if this video confused you any with the conceptual, with me bringing in some of the concepts, keep an eye out for the videos that are coming, doing a more conceptual deep dive of OSPF. I have some on the agenda here. Check the description below for any resources that I may post to help you more understand more of both the OSPF routing protocol from a conceptual perspective and from a configuration perspective. And yeah, go ahead and leave a comment below if you have any feedback or any questions. I will try my best to answer them. But yeah, you guys have an amazing time. I hope you enjoyed this. Leave a like if you enjoyed, and thanks for watching. Yeet!